Hi everyone, welcome to my new tutorial video. In this video I'll be creating a Spark application which takes data from S3 and puts it into RDS, and then we'll run the Spark application through local IntelliJ. Then we'll run through a Spark Summit, and then we'll run it on Docker, and finally we'll set up Kubernetes on GCP and run it on Kubernetes exactly the same way it works in production. First let's download the dataset from Kaggle. I'm using IMDb actors and movies dataset. Download it, open Jupyter Notebook. I'm using a Spilent kernel to run a Scala on Jupyter. Read the CSV file. Let's do df.show. Now I'll write it in Parquet format in output folder. Okay, here we have Parquet file and also these additional CRC file which we don't need it. So let me do coalesce one and then write file name in same folder. Yeah, here we are. We have Parquet file, and we can see converting file from CSV to Parquet reduces significant memory consumption. Let's see this data frame. Now open your S3 bucket. Create your bucket. And then create folder. And upload the Parquet file. Yeah, so it's uploaded. But this data is huge, and let's say we have a staging environment which just takes a small portion of this data. So I'll limit the data to 50,000 and write it. Create another staging folder and load that Parquet in here. Open RDS, DB instances, create database, I'm giving data loader as username. Assign password. Public access, yes. Create database. Click on security group. Edit inbound rules. Whitelist your public IP. Open dbeaver. Copy endpoint and paste it. Give username and password you just set. Create database. Now switch to this database. Okay, then create a schema. refresh it, and now create table. Now let's do select count star. Yeah. So this is my code. This is AWS credential, S3 path, my RDS configuration. We will pick batch size of 50,000 so that it doesn't take entire data at once. Now I'm repartitioning it and then we'll load to RDS. This is the JDBC URL. You can take it from dbeaver also. Now let's run it. And here we can see progress in a Spark UI. Now you can see we have done 200 partitions here. And I have 8 cores, so 8 jobs can run in parallel at any point. Now it's completed. Let's check the count. And yes, we have 50,000. These access keys and secret keys should not be here. We'll be putting it in environment variable. As of now, it's in local only. Let me add AWS secret key and AWS access key here. Replace it with variable. Now these password will be encrypting and encoding it and will save it in AWS Secret Manager. Open AWS KMS. We'll keep it default. Click next. Give it a name, demo master key. Next. Select users whom you want to be key admin. Next. Select users which can operate this key. We'll select both. Finish. Open Secret Manager. Store a new secret in key value pairs. JDBC URL demo DB. We will directly put it here. We don't need to encrypt it. Demo DB password. Here we will give some encrypted password later. And give DB username here. Give name to the secret. Click next. Store. Go to IAM. Select user whose credentials you'll be putting in the code. Add permission and add this secret manager read-write access. Now go to this encryptor file. Copy this master you just created using KMS. Click edit. Put this customer master key in environment variable. Apply OK. Now run the file, and here we have encrypted value for our password. Put it in secret manager. Go to the video links in comment section to understand how secret manager is properly implemented. Again, run this. And we have our Spark application running properly with no secret credentials present in code. Let us run this in using a Spark Summit. Make sure you have all this in your Windows environment variable. Go to environment variable, and here we have all passwords. Now do sbt compile, then sbt assembly. Run this spark submit command with only 2 executors. Make sure you have commented this, as we will be providing configuration through Spark Summit. And here we have our Spark application running again. But we have only 2 executors as provided in our Spark Summit command. Use this YAML and pass these things from environment variable. Now come to third part. Run a Spark application on Docker. Put the jar in Docker volume. Use a Spark Bitnami image and have multiple workers and its configuration in Docker Compose. Create this network using docker network create my network command. Now do Docker Compose up. Here we have all masters and workers up and running. Do Docker PS. Then docker exec master container /bin/bash. Do cd myjars, and here you have the jar. Use this Spark Summit command and run your Spark application from inside Docker container. Here we can see again in a Spark UI that a Spark application is running. And here we have 2 workers, each has 4 executors. Now let's come to the main part, Spark on Kubernetes. Search Kubernetes on Google Cloud. Switch to standard cluster. Go to node pools. You can change number of nodes. Let me select end to standard 4. Rest of the things will remain default and created. You can adjust quotas by just sending a mail, and it will be done in just 2 minutes. I've done it here. My cluster is here. Wait for some time till it is up and running. Now click connect. Press enter. Create namespace. I'm giving eSales a staging. Now set context. Create persistent volume claim. This is the YAML file. All the YAMLs are present in GitHub repo mentioned in the description. We'll show you in some time. Apply it. Create a Spark role YAML. This is the Spark role. Apply it. Create a Spark role binding. Yeah, this is our Spark role binding. Apply it. Now create a Spark service account and apply it. Create a Spark headless service. and we'll apply this too. So this is the folder location where you will get all these YAMLs. Now build your Docker file. I am giving random tag ID 2507, which we will fix it later. And then Docker push. Now comment the second line and create another image, because this will just be the executor and we don't need jar file to be there in a Spark executor. This is my Spark job YAML. Put your image here. Let me copy it to Kubernetes cluster. Change tag IDs. And apply it. Now you can see your pod is getting created. I put it on watch mode and you can see executors are also up and running. You can check the logs. Yeah, this was normal job, which just prints a data frame, not the one which we were using before. You can check the logs. Yep, it is working fine. Open my config map.yaml and you can put all your credentials here. Copy it, paste it in my config.yaml on Kubernetes and apply it. Put this default in your Spark job in env from which this Spark job will refer for environment variables. Now do kubectl get nodes. These are the external IP address. Copy them. Go to your RDS database. Security groups. Edit inbound rules and allow traffic from these IPs. This is my Spark job 2, which puts data from S3 to RDS. I have added my config map here. Now apply this YAML. And here we have the job running. We can see the logs. Let's check the dbeaver if the data is getting populated. Yep, data is getting inserted here. Do port forward on 4040 and check a Spark UI. Here we can see a Spark UI, but there is a problem. We have only one pod. We made a mistake and executors didn't spin because of that. Go back to code. And comment this part which doesn't allow executor to start. Build the jar again. Again, docker build, docker tag, docker push. Tag it with something new. Delete the previous pod. Fix the YAML tag to the new one. And apply the YAML. Here we have executors also running. Check Spark UI. And we can see two executors are there. Now let's fix this tagging thing. As of now, I was tagging to some random numbers. Now I'll be tagging each of my image with git commit ID, which I'll be automating through Jenkins. Let me do git commit, git push, and this is my commit ID. I will now be tagging my image with this ID. Again, docker build, docker tag, docker push. We can fix this in a Spark YAML. But as of now, we are putting all our image in public Docker Hub repository, which is not the right way. Search for Artifactory, and we will be replacing this thing. Create repository, give it a name, region, and create it. Click on add principal. Let's create SVC account first, and then we will come back here. Go to IAM admin. Create service account. Let me name it GCP service account pull push artifact. Assign the role of artifact registry service agent. Give any Gmail ID which we will be using. I'm giving mine, and done. Now in this principal section, add the SVC account just created. Let me give it editor access. Save it. Click on the service account. Keys, add key, create a new key. And here we have a JSON file. Authenticate the service account. Now let me change something in code. Yeah, now do git add, git commit, git push. Okay, I forgot one step. So you even need to do SBT assembly to rebuild the jar. Copy this commit ID and do docker build. We will be pushing our image here. Copy this path and do docker tag. Then docker push. Go to your artifact registry, and you can see this image is present. Come back to your Kubernetes cluster, connect it. Now do docker pull. We are able to pull image from cluster. But there can be issue while pulling this image from a Spark YAML. It will not have access to do that. So click on upload. The credential file, you can upload it. Convert it to base 64. Copy this. Paste it here. And now copy this GCR JSON YAML and paste it on Kubernetes. Apply the YAML. and your secret is now created. Go to your Spark job. We have updated image. We can even update the executor image. You can comment it and give a tag and do Docker push for your executors. Have GCR JSON key in your secrets. Copy this YAML, paste it in Kubernetes. Create a Spark headless service for your job 3. Paste it and apply it. Now apply your Spark job 3. See your pods in watch mode. Okay, by mistake, pod name is still my Spark job 2. Let me change it to job 3. Yeah, apply it again. I have executors running. You can describe the pod and check details. This is my image successfully pulled. Now let's automate this entire thing using Jenkins. Create VM instance. I am selecting E2 standard. Allow traffic. Yeah, now my instance is up and running. Install JDK. Install Jenkins. Let me copy it and paste it here. Now enable Jenkins. And then start Jenkins. Go to Jenkins user, then vi sudo. Add Jenkins and give root privileges. You can restrict it, but I'm giving full privilege for now. Then restart your Jenkins machine. When it restarts, you can create admin user, fill all these details and start it. Now you start one more VM, which will be slave machine. Allow traffic. Now SSH into your slave machine. Install JDK. Then install Kubernetes. Copy paste all these commands. And then check version to see if it is properly installed. Open Kubernetes cluster. Go to IAM and admin. Add user with access to Kubernetes engine developer. Go to roles. Yeah, looks good. Go to role binding and make sure this user is already added here. If not, then add it. Come to your slave machine and do gcloud auth login. Copy this URL, paste it, choose the account, copy this credential and paste it. Connect with your cluster using this command. Cluster 1 is your Kubernetes cluster name. Get your zone from here. And project name you can grab from here. Okay, it says you need to install this plugin. Use this link, copy it and paste it. Okay, you need to do sudo. Let's try with kubectl get pods. Okay, let me run it again. Now do kubectl get pods. Yeah, it's running fine. Now install SBT on the slave machine. Paste this. Check SBT version. Install Docker. Now copy paste these commands. Make sure in gcloud auth list it is pointing to that account which you have given in a Spark role binding. Search artifacts. Check if that user has access to our artifact registry. Then run gcloud auth config for Docker image artifacts. Now open puttigen and generate key because slave machines should have a proper user. Let its name be a prod user. Copy it. Paste it in here. Now do sudo su and then switch to prod user. Go to Jenkins. Get private key for prod user. Save it as prod user creds. Open it, copy it. Now to add the slave node to Jenkins, click on build executed status, new node, give it a name, number of executors be 2, search for its remote root directory, paste it, give appropriate labels, launch agents via SSH, provide slave IP, In credentials, add it. Select SSH username with private key. Give user ID. Give some description. Provide username, prod user and private key. Paste it directly. Now add it. Select non-verifying verification strategy and save it. So we have added one slave machine. Go to logs and agent should be successfully connected. One mistake I made, I kept disk size of slave very small. Make sure you have more disk space. This was really very less. Now generate another key for GitHub. Copy this public key. Go to GitHub settings. Add new SSH key. Give it a name. Paste public key. Manage Jenkins. Go to credentials. Add credentials. Again, same thing. Put GitHub credentials as ID. Give description. Give the username. Now provide private key. Export it. Open in Notepad. And create it. Install this rebuilder plugin. Now create a Jenkins job. Click OK. Give GitHub project URL. You should be giving URL present on address bar. By mistake I did this, which will be fixed later. Create sample pipeline. Give labels to the agent what you have mentioned while setting up slave. Add parameters which will be provided from outside. Branch name, SVC path name, build path name. Now provide environment variables. Get commit ID and will be using it as Docker image tag. Add checkout step. Provide GitHub credentials what you created few minutes back. Now fetch commit ID. Add SBT compile and SBT assembly step to build jar. Now build and push image. These are the commands. Use the commit ID as tag ID. Do docker build, docker tag, docker push. Create these two folders in your slave machine. One for job YAML and one for service YAML. And add another step to copy YAMLs to these locations. Now delete pod if it already exists. Otherwise apply YAMLs. Now this is interesting step. The image name has to be parameterized as it contains commit ID as tag and we have to put it in a Spark job. So we pass that as parameter. Now this part will remain as is and tag will be passed through Jenkins. With the command, with this command, we'll be able to inject image from outside. Save it and build the job. As mentioned earlier, we encountered few failures in here. Let's fix the GitHub URL and copy the GitHub URL and paste it. We can see here all steps completed fine. But there is some issue while pushing image to Google Artifactory. Go to slave machine. Okay, so our user account is not there. Let me add my user account. Do gcloud auth login, copy it, paste it. Now check cluster access and configure Docker access. Check Kubernetes access. Yep, looks good now. Let me rebuild it. Running fine. Yep, it ran fine. You see pod was deleted then created again. Do port forward to 4040. Check Spark UI. And we can see things are running fine.